Alright, so the second part of us solving a system by graphing is determining how many solutions there can be for a system. So there can be three different solutions. There can be one solution, no solution, or infinitely many. Depending on which one it is, depends on what vocab word you could be using. So if it's inconsistent, so a system is declared as inconsistent, that means it has no solutions. If a system is declared as consistent independent, that means it has one solution. And if I say a system is consistent dependent, that means there's infinitely many. So please make sure you understand infinitely many solutions means there's so many solutions that I couldn't even count. So there's too many to count. So for this first part is just filling in the boxes, making sure you know what the graphs look like if I'm going to be doing these solutions. So for this first one, if I have one solution, it's because it only intersects in one spot. So with that being said, however many intersections there are is how many solutions there are. So for this one, the lines intersect, so I'm filling that in. That means that the lines had different slopes. For the next one, for no solution, they never intersect, which is why it's a no solution. The lines are parallel. Since they were parallel, the lines had the same slope, but they would have different y-intercepts. And then last, if I have infinitely many solutions, you're going to graph the line the same 2 times. So after you graphed it, you're noticing it's the same thing. So that means the lines had the same slope and the same y-intercept. Let's take a look at an example now. So for this first one, it says graph the system, determine how many solutions there are. So this is in slope-intercept. So remember, I'm going to use my y-intercept and my slope. So my y-intercept means I put a point at 1 on the y-axis. My slope is 2 over 1, so I went up 2 and over 1. Then I drew my line in, and I came back and I graphed the second one. My y-intercept's at -3, and my slope is 2 over 1, so I went up 2 again and over 1. Notice that these lines are not intersecting. Do your best to draw straight lines because they should be an even distance apart. I just didn't do a very good job showing that. So since these will never intersect, my answer is no solution. Let's take a look at another one. For the next one, notice it's not in slope-intercept form. Notice I'm in standard form. So I did the cover-up method to find where my intercepts would be. So for this first one, I covered up the y's, and I got x equaling -3. For the second part though, I covered up the x, and I got 3y equal -3. So I had to divide and find the y-intercept at -1. I did the same thing for the second equation as well. I covered up the y, and I got 3x equaling -9, so I had to divide by 3 and get -3. Then I covered up the x, I got 9y equaling -9. I had to divide by 9 and I got -1 for the y-intercept. So graphing these two lines separately, so for the first one, my x-intercept was at -3. So I put a point at -3 on the x. Then I came back and I did a y-intercept of -1, so I put a point at -1 on the y-axis. I went ahead and drew in my line. Then I come over and I look at my second line. My second line also has an x-intercept at -3 and also has a y-intercept at -1. Notice it's the exact same line. So since it was the same line, there are infinitely many solutions because it will intersect infinitely many times. Alright, let's take a look at one more here. It says graph the system again, determine the solution. So again, it's in standard form, so I would want to do the cover-up method. So maybe you pause the video at this point and try it on your own to make sure you get the right ones. So if I covered up the y, my x-intercept should be at -15. If I covered up the x, I get -3y equaling -15, and I would have to divide by -3 to get a y-intercept of 5. Then I'm going to do the same thing for the bottom equation. I cover up the y, I got -2x equaling 18, so I had to divide and get -9. I again had to cover up the x, I got 3y equaling 18, divided by 3, my y-intercept's at 6. So now I'm going to graph these. So for this one where it said x-intercept at -15, when I was counting out, I stopped at 10, so I needed to extend my graph to -15. My y-intercept's at +5, so I counted up 5, and then I went ahead and drew in my line through those 2 points. Now over here on this one, my x-intercept was at -9 and my y-intercept is at +6. So then I went ahead and drew in my line. Notice they intersect at one spot, so that's how I know I have one solution. So remember, there's three types: one solution, no solution, infinitely many, and you're going to graph those systems the same way we've been graphing linear equations. There's one more type, just to remind you. You might have horizontal and vertical lines. So remember to graph these. X equaling 2 means I go to the 2 on the x-axis, draw a line through that point so it intersects. Then for y equals -3, I go to -3 on the y-axis, draw my line through that point, and notice they intersect one time, so I have one solution. Alright, one solution, no solution, infinitely many, all based on how many times they intersect. That's how many times you'll know how many solutions you have.